Today is our first day in our exponent unit, and an exponent is just a short way to write multiplication. So in this first example, I have -3 multiplied together 1, 2, 3, 4, 5 times. So instead of having to write 5 -3s, I can write -3 one time, and I'll write to the 5th power. That means I have 5 of them multiplied together. In the next example, I have x plus 4 written down 3 times. So instead of writing it down 3 times, I can just use an exponent, and that means I have 3 x plus 4s multiplied together. On the next one, I could do 5 times 5 times 5 because I have 3 5s multiplied together. Or you can also evaluate this on your calculator. And I'll press 5. And to get an exponent, there's a little caret key above the division sign on the graphing calculator. You'll have to look for it if you have a different one. But you should have a caret key somewhere on your calculator. And that is just the exponent. So exponent 3. And I get 125. And then for 2 to the 3rd, I will get 8. I could also do that as 2 times 2 times 2. I'll still get 8. On example 3, I'd like to look at a pattern. 10 to the 4th is 10,000. It's a 1 followed by 4 zeros. 10 to the 3rd is a 1 followed by 3 zeros. 10 squared is a 1 followed by 2 zeros. 10 to the 1st is just 10. And notice every time I drop a 0, I am dividing by 10. So it would follow that 10 to the 0, if I divide 10 by 10, I'd get 1. And then if I continue my pattern, I went 4, 3, 2, 1, 0. And -1, you're still, as an exponent, I'm still dividing by 10, so that's going to be 1 over 10. And then this is going to be 1 over 10 times 10, or 10 squared. So that negative exponent will flip it to the bottom. So notice I changed it to a positive exponent in the bottom. When I flipped it, it's now 10 squared in your denominator, which leads us to 2 properties. If you have a number to the 0 power, that is 1. It doesn't matter if the number is 6, 25, -3. If you have a number to the 0 power, it's always going to be 1. Similarly, if you have a negative exponent, you can rewrite as a fraction over 1. You'll flip that to the bottom, and you'll have b to the n. Your exponent becomes positive when you flip it and write a reciprocal. Let's look at the next page. Using these properties, notice everything in here is to the 0 power. So that's just 1. There's a bunch of stuff in here, but it's all to the 0. So that's just 1. On C, the 6 is not to that exponent. Everything in the parentheses is, though. So this is going to be 6, and then everything in the parentheses to the 0 becomes a 1. So this will just be 6 times 1, which is 6. And on my next example, 4a, that was not to the 0. Just what's in the parentheses was to the 0. So that'll be 4a times 1, which is just 4a. For example 5, I'm going to use my other rule. And when I have a negative exponent, I'm going to write a 1 on top and flip that to the bottom, and my exponent becomes positive. On the next example, the negative in front of the 12 is not an exponent, so it doesn't flip. And the negative 12 is not to the exponent of negative 2. If I wanted the negative 12 to that exponent, I'd have to put that in parentheses. But it's not in parentheses, so the negative 12 will stay on top. And that x to the negative 2 will flip to the bottom, and that becomes a positive exponent now. If it starts on bottom and you have a negative exponent, it will flip up to the top. So this becomes 5h to the 7th. On our next example, the 3 is not to that negative exponent, so the 3 still stays on top. X to the negative 2 will flip to the bottom. When you flip it, you become positive on your exponent. The y does not have a negative exponent on it. It has an exponent of positive 1, so it stays where it is located. And for our last part on example 5, the 4 does not have a negative exponent. The c does not have a negative exponent. The d does, so this is going to be d to the 5th on the bottom. I have a 9 on the bottom. I have an a on the bottom. The b has a negative exponent, so it will flip up to the top. And that completes today's notes.